Today we're going to discuss something about Linux. Specifically, I'm referring to Linux drivers, which is referred to as modules. So when you boot the Linux system, the component of this Linux system that is delegated to communicate to a specific hardware such as a hard disk, mouse, keyboard is by Linux design and of course by the principles of Unix. This delegation of this specific external hardware that is of course unknown during the time of the core operating system of Linux was developed. So this delegation of a potentially unknown hardware that can be attached to a computer running in Linux is called the driver. So yes, it is unknown, but it follows standard interfaces that how this driver should behave, such as open, close, and send commands. So that's the principle. So now it's almost time to begin programming. And so we will be discussing here about modules and kernel programming. So these two things are different. So modules, Linux driver programming or Linux modules is a smaller or more specialized type of Linux expertise, which is more of focusing on the hardware that is going to be attached into a Linux operating system. So Linux kernel development is specific to a hardware that's being developed for that module or for that driver. However, there is an interaction to the core kernel abstraction because the driver is just a tenant inside a kernel. Okay, so in this tutorial here, which is the basic, the ABCD of Linux drivers, it is of course possible to develop a complete but useless driver. This useless driver will show the fundamental basics interfaces that every driver conforms. And we are not referring to any specific device class here, as we are striving for the most generic driver. So I highlight here in pink the more important concepts, while the yellow are the more common concept, but I highlight in pink the deeper concepts that should we should focus more and we should think a little bit deeper. So here you can see the kernel items has been highlighted in pink because the driver has to use existing kernel constructs. These are called as kernel items, and it could be in a form of a function or a variable or a header file or a macro. Okay, so again, if we go back to the diagram here, I would like to draw something. Um, so if the analogy is, um, this would be the Linux kernel. Okay, Linux kernel, and it is the most generic piece of C code that represents how an operating system should uh, should be programmed in C. Like I said, the specific part, which is by design delegated to a notion of what we call as a driver. For example, here, this would be this would be the driver. Sorry about that. And like driver. And in order for the driver to be to interact with a kernel, think of the driver as a tenant, a guest inside a kernel. The driver has to expose interfaces, okay, and whereby the kernel can use, okay, kernel can use will call into the interfaces, and not only that, but a static library here, which are gonna usually is running on a user space. Anything that runs outside a kernel is a user space, and it would be a static library, or this would be a library lib. Usually there is an association between the lib and the driver there, and the application user app here, which is the executable, the exe, has to be associated to the library, and this library could be either this could be either static or dynamic. So if it's static, so its extension would be dot .a, and the dynamic would be dot .so. In Windows, the programming it would be the DLL, dot .dll. In Linux, it's dot .so. So so this is usually how it looks like. An app is linked to a lib, and the lib talks to the driver. The other way is we can bypass the library, so we don't really need the lib here. So we might not need the lib, but in such cases, dev interface in the here, dev like my my drv should exist, and the application can directly communicate to this special device there. That can also work, but there are some set up to do that. Or you can use a library. It depends on how you design the driver. So let me color this because I like to emphasize this. There, set. Okay, so again, this is the bigger area here is the user space where there's an app which is associated with a library. It could be a static or a dynamic, and the library talks to the driver, or the app can directly talk to communicate to a slash dev my drb special file, because this driver can also be made to communicate to this special file. Okay, it's also possible to do that. So again, because of the standard interfaces in the driver, like open, close, and read or send commands, you can communicate to the driver, and the driver has privileged access to hardware as it is running beside the Linux kernel. So you should be very careful when doing the driver, as it could crash the system. So going forward here, this would be the hello world of Linux kernel. This entire code here would be the hello world. It is doing nothing. It just loads and it just adds interfaces that is called when the driver is loaded and then when the driver is unloaded. That's it. That would be the very basic so um, flow. So of course you need to be familiarized with the bash shell. Do not pretend to be able to understand all of this without basic understanding of the bash shell. The operation of the bash shell in the command line is prerequisite to understanding Linux, the smallest Linux, any basic Linux development. So that's it for now, and continue to